Hello everyone. Today we will study the topic statistics and probability, and this class will be helpful for GATE examination and all three exams of NIC, that is Scientist B, Scientific Officer and Technical Assistant. So let's start our class, and our topic is, as you know, statistics and probability. Yes, today we will study statistics and probability. Before probability we will study statistics. And what is statistics? Statistics is collection of data. So my dear students, statistics is nothing but collection of data. And my dear students, data is of two types. One is ungrouped data, and the other is grouped data. Right now you just understand the classification of data, and after classification of data, one by one I will tell you everything, that the example of ungrouped data and grouped data and the further classified data of grouped data. I will define you everything. Just keep patience and just watch the class. So grouped data is also of two types. First is discrete frequency distribution. And the other is continuous frequency distribution. Okay, so here you see the statistics is collection of data, and data is of two types. First is ungrouped data and the another is grouped data. Further, grouped data is classified into two parts. One is discrete frequency distribution and the other is continuous frequency distribution. So now we will see, first one was ungrouped data. So first we will study ungrouped data. For example, I will show you. There is a data given. Suppose these are the values of x: 3, 9, 5, 3, 12, 10 and 18, 4 and 6, 4. So here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 observation, and you can see if 3 comes 2 times, we will write it 2 times. If any number comes 2, 3 or 4 times, we will write them that many times we will write them, as you can see. So this kind of data is called grouped data. Okay, So you got to understand that what is grouped data, ungrouped data, sorry, it is a ungrouped data. Now you will see grouped data. Next is grouped data. This was ungrouped, and next is grouped data. So in grouped data you will see, I will write down, suppose the values of x is 2 5 6 8, 2 5 6 8 10 10 and 12, 2 5 6 8 10 and 12, and suppose 2 appears 2 times, 2 appears 2 times, so I will write down 2 times. 5 appears 8 times, 6 appears 10 times, 8 appears 7 times, 10 appears 5 times, and 12 appears 8 times. So here you can see, if any number, any data repeats itself, then we will write down that how many times it is repeated. So this is called the frequency. Repetition is called frequency. So here you can see the difference between grouped data and ungrouped data. But earlier I told you that grouped data is also classified into two types. First one was discrete frequency distribution and the second was continuous frequency distribution. So this is our discrete frequency distribution. Discrete frequency distribution. And the next will be continuous frequency distribution. Next we will see continuous frequency distribution, because first type was discrete frequency distribution, and the next is, for this you will see, okay, now I will draw another table for continuous frequency distribution. Continuous frequency distribution. Suppose here I will write the values of x, and here I will write the frequency. Suppose the value of x can be between 0 to 10, and it appears 12 times, and for now I will say 10 to 20, and it appears 18 times, the frequency is 18. For 20 to 30, the frequency is 27, and for 30 to 40, frequency is 20, and for 40 to 50, the frequency is 17, and for 50 to 60, frequency is 6. So here you can see the value of x can be between 0 to 10, and in the same way 10 to 20. So this kind of data, this kind of grouped data is called continuous frequency distribution. I hope now you got to understand about the classification of data. So that is how we classify our data. So first you show the statistics. Statistic is nothing but the collection of data, and data is classified into two types, ungrouped data and grouped data. And grouped data is further classified into two types, that is discrete frequency distribution and continuous frequency distribution. Now the most important thing now I will tell you is, here you will see measure of central tendency. measure of central tendency. This is very important. So you will see the measure of central tendency. Measure of central tendency. Measures of central tendency are of three types. First is mean. Second is median, and the third is mode. So all these are the measure of central tendency. And what they do, what is the significance of these measures of central tendency, mean, median, mode? It tells us about the where data points are centered. So it tells us about where data points are centered. Data points are centered. So this is the significance of measures of central tendency. Now you will see there is another concept, that is measure of dispersion. The next important, you just keep patience. I will tell you everything. You step by step you will get to know everything. You have to just keep the patience, and don't forget to like the video. First like the video, and if you are new to this our channel, so subscribe our channel. And if you like the videos, it motivates me a lot, and I will try to provide you complete syllabus of NIC for GATE and also the NTRO exam. So without wasting time, let's move to the next topic, that is measure of dispersion. Measure of dispersion, we will see what is this. Measure of dispersion. This topic is very important for every exam, and for NIC exam definitely there will be 2 to 4 questions from the statistics and probability. Now you will see in all 3 exams, for scientist B, scientific officer and technical assistant, and for every exam where probability comes, the statistics is the basics for the our probability, statistics and set theory. So all these topics are very important to understand the probability. So now we see measure of dispersion, and what does it say? It tells us about how data are scattered how data are scattered around a measure of central tendency. So measure of dispersion will tell us about how the data is scattered around a measure of central tendency. A measure of central tendency are of 3 types: mean, median and mode. So now I will show you from an example. Let's take an example. Now you will get to know everything. Now you will get better understanding of everything. Suppose there is a batsman A. Now we will see the data. Suppose there is a batsman A. And batsman A scores some runs in 10 matches. He got to bat, he plays in 10 matches and he scores some runs, he makes some runs, and now we will write down the run made by the batsman, scored by the batsman A. So we will see he scores in first match 30, then 91, then 0, 64, then 42, 80, 30, and then 5, and then 117, and then 71. So these are the scores of batsman A. First 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in 10 matches, these are the scores for batsman A. And there is another batsman, batsman B. Now we will see the score of batsman B in 10 matches. So the score are 53, 46, 48, and 50, 53, 50, 53, 53, 58, 60, 57, and 52. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Here you can see the score of batsman A and batsman B. So could you tell me what kind of data is this? This is grouped or ungrouped? Clearly you can see there is no frequency terms. We write down if he scores 53 two times, so we just write down 53 two times. That's why it is a ungrouped data. This is a ungrouped data. Now we will find out, here I will write down. Now we will find out the measure of central tendency. Measure of central tendency, the first one is mean. So now we will calculate mean. And mean for what? For ungrouped data. This is a ungrouped data. For ungrouped data, grouped data, we will find mean. Mean for A. A के लिए हम find करेंगे mean को. So what is the formula of mean? The formula of mean is sum of observation divided by number of observation. Here you will see number of observations are 10, and here you will put down the data and the value will come 53. You have to add all the 10 observations, and now you will see the mean for batsman A scores will be 53. In the same way you will calculate for batsman B. You will find out the mean and it will come 53. So the mean is same for both. You will see the mean will same for both. Now we will find out the second type of central of tendency, and the second is, I have already taught you, that is median. Now we will find out the median, and median for ungrouped data, because this data is ungrouped data. So first we will calculate for batsman A, and you know how to find median for ungrouped data. First we will write the data in ascending form. We will write down the data in ascending form. First we will write the data in ascending form. So now first we are finding out the median for A, for batsman A data. So I will write down this in ascending form, and you can see the lowest score was 0, then 5, then 30, then 42, then 64, then 71, and then 80, then 91, and then 107. So we write down the ascending form. The data, ungrouped data, is written in ascending form. Now there are two conditions. Here you will see these observations are, number of observations are 10. Number of observations are, you can see, is 10. So there are two conditions. The first one, if n is odd, then median will be n plus 1 by term, n plus 1 by 2 term. This term will be the median. But you can see 10 is odd. So for odd, if n is even, 10 is even, n is even, so the median will be n by 2 plus n by 2 plus 1th term divided by 2. So this will be the formula for if number of observations are even. So now you will see the value of n is 10 by 2 plus 10 by 2 plus 1 divided by 2. Here you will see now it will be the 5th term plus 6th term divided by 2, and our 5th and 6th term are, you will see, this is 5th, this is 1 2 3 4 5 6, so 42 and 64, 42 and 64, 42 plus 64 divided by 2, and this will also come 53. Now you will calculate median for B, and it will also come, median will also come 53. So we find out that for batsman A and B, mean and median both are 53, 53, 53, 53. It means the performance of A and B is same. It means performance of A and B is same. Performance of A and B is same, because we are getting mean and median is same. Mean is also same and median is also same for both the batsmen. So it means the performance of A and B is same. But look at the data. Now look at the data. You will see batsman A score minimum score 0 and maximum score 117. And for batsman B, you will see the minimum score was 46 and the maximum score was 60. You will see the maximum score was 60. So you will see the variation is here more. In batsman A, the variation is for batsman A is more, 0 to 117, 117, and here you will see from 46 to maximum score is 60. So the performance of for the both of batsmen, the performance is not the same. Now that's why we need measure of dispersion. Measure of central tendency is not enough to understand the data. Now we are in need of what? We are in need of measure of dispersion. So we will now look at the measure of dispersion. So before I will show you something. Now look at this. I will draw this. If I draw 0, 10 and 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180. So if I draw, you will see for batsman A once score 0, batsman A once score 0, and also scores 170. That was the data was just look at the 117. So I will draw 100 and here you will see, and that was 91. One score was 91 and 71 and 80, and 2 times he made 30, and he also made I think that was 7. So this kind of distribution you will see batsman A. So batsman A score was this, but for batsman B you will see, for batsman B the score was between 46 and 60. 46 and 60. So data was distributed only here. You will see for batsman A, batsman B. And this is for batsman A. So you can see the distribution. Here you can see the distribution of batsman A score and batsman B.